Welcome to the Deep Dive. Today we're tackling a mission that is, well, critical for our entire digital world, the shift into the post-quantum era. I mean, think about it. Everything you do online, your finances, your secrets, it all rests on the assumption that certain math problems are basically impossible to solve. But that assumption is crumbling. It's being hit from three sides. Quantum computing on the horizon, new breakthroughs in math, and attacks from AI that are happening right now.
That's a perfect way to frame it. The algorithms we've relied on for decades, like RSA and ECC, they're built on the difficulty of factoring large numbers. And we've known since Peter Shor's work that a powerful enough quantum computer would make that, well, trivial. It could just shatter that security.
Okay, let's unpack that. Because this isn't some science fiction threat anymore, is it? It's immediate.
It is. It's happening now because of a strategy called Harvest Now, Decrypt Later, or HNDL.
So adversaries are just vacuuming up encrypted data today.
Exactly. They're archiving massive amounts of it. They're just sitting on it, waiting for the day that quantum computer, we call it Q-Day, comes online to break it all open. And that creates this asymmetric risk. You know, if you have data that needs to stay secret for 20 or 30 years, think genomic data, state secrets, it needs post-quantum protection today, not in a decade.
Right. The data is already vulnerable. So where are we with the official solutions? What tools are actually being deployed to fight this?
The official response is coming from NIST, the National Institute of Standards and Technology. They finalized a set of new standards in August 2024.
And these are based on new kinds of math, right?
That's right. They've moved to lattice-based cryptography. For key exchange, the standard is FIPS 203, which is based on an algorithm called Crystal's Kyber. It's fast, and it has small key sizes.
And for digital signatures?
For signatures, the primary one is FIPS 204, based on Crystal's Dilithium. But, and this is crucial, they also standardized a backup.
A backup?
Yes. FIPS 205, which comes from CINCS plus IAS, it's hash-based. You can think of it as an insurance policy, just in case a major weakness is ever found in the lattice math.
Okay, so that handles the future quantum threat. But you mentioned AI is attacking us today. How does that fit in?
Well, the AI isn't trying to break the fundamental math, not yet. It's attacking the implementation.
How so?
There's a new method researchers are calling cool and cruel. It's a hybrid technique. It combines classical attacks with machine learning. The AI basically learns to spot shortcuts or patterns left by human error. For instance, if a developer uses certain performance optimizations, the AI can learn to exploit those specific weaknesses much, much faster than a classical attack ever could.
So it turns a simple coding choice into a major vulnerability.
An immediate one.
So if you're a systems manager listening to this, what does this all mean for you right now? What's the actual migration plan?
The global consensus is pretty clear on this. It's called the hybrid migration strategy.
Hybrid. So you're running two things at once.
Exactly. You perform a key exchange with your current classical algorithm like ECDH and a new post-quantum one like Kyber at the same time. Then you combine the results.
Hold on, though. Running two complex algorithms, doesn't that just grind performance to a halt? What's the trade-off there?
You do take a performance hit, yes, but the security rationale is just... it's ironclad. It's a belt and suspenders approach. If the new PQC algorithm turns out to have a flaw, which has happened before, your classical layer still protects you. If Q-Day arrives, the PQC layer is your defense. Your security only ever goes up.
So this is clearly not just some software patch. It's a systemic overhaul of our entire digital trust infrastructure.
It is. And that brings us to the real endgame here, which is something we call crypto agility.
Crypto agility.
Yes. With AI and quantum computing moving so fast, systems have to be built to be flexible. You need the ability to swap out an entire cryptographic algorithm almost instantly. And that leaves us with a pretty provocative thought. If the goalposts are always moving, then the very definition of a secure parameter is no longer fixed. It's a moving target, and it demands constant, unending vigilance.